Good day, I greet through the audience my coursemate and Dr. Nordin. We are the students under the Faculty of Engineering, University Putra Malaysia doing the Fluid Mechanic Pump Selection Project. My name is Leong Jun with metric number 202454.
My name is Krishna and my metric number is 201734.
My name is Wafa. My matrix number is 203125.
My name is Muhammad Ali Irfan bin Shamsaidi. My matrix number is 200417.
Now, without further ado, I would like to explain the question to the audience. The question is, now we have a distillation column located 20 meters below a freezing crystallization unit. And now we need to move the fluid in the distillation column, which comprise of acetic acid and water, from the distillation column to the freezing crystallization unit. During the pathway, there will be a fully open gate valve, a pump, and a ball type check valve, and there are two 90-degree standard elbow that will contribute to the minor losses of the systems. And the composition of the stream is comprises of 0.987 by mass fraction of acetic acid and 0.013 by mass fraction of water. So now we are going to look into detail how is the minor losses affecting the flow of the system, and how should we select appropriate pump for our system. Now, without further ado, I would like to invite my group mates to explain about the topic. Now I will, Krishna, you can start.
My part is SSC.
I start first.
All right.
So, as we can see by the figure, we have distillation column, and at the suction pipe we have fully open gate valve, and we have pump. And then at the discharge, we have ball type check valve, standard and two standard elbow, and then freezing crystallization. So here we determine that at the suction pipe, we are using nominal pipe size, which is DN200 based on schedule 40. And for the discharge, we are using DN125, also schedule 40 steel pipe. And the suction diameter is 0.2027. And the discharge pipe diameter is 0.1282, and the area at the suction is 0.03226 meters squared, and at the discharge is 0.01291 meters squared. As like Lee said before, our acetic acid the composition is 0.987, and the water is 0.013 kilogram per kilogram. This is based on our third pump at our Excel energy balance calculation. We are using the distillation column. The component, the substance is at 95 degrees Celsius. At the inlet at the distillation is at pressure 0.637 atm, and at the outlet is 1 atm. So we got the Q, which is the volume flow rate, is 137.895 gallon per minute. And then we have elevation at from point 2, which is 20 meter from the fluid of the distillation up until freezing crystallization is 20 meter. Now I'm gonna pass up to my next presenter.
All right, Krishna, can you please explain to us the system resistance curve?
I'm going to present SRC. So SRC represent the resistance offered by the system. So the pressure developed by the pump is actually high enough to overcome the resistance developed by the system. So this pressure is known as total head. Total head can be divided into two components, which is total static head and friction head. SRC is really important when calculating energy losses using at different flow rates. So the graph over here, we actually used an interval of 50 gallons per minute. We used the data we used to plot this graph is actually in the attachment we're going to attach later. And SRC is really important. If we any error in calculating SRC, we might end up choosing a wrong pump, wrong centrifugal pump. On the other hand, if we add more safety margins in SRC calculation, we might end up selecting oversized pump. So we must calculate SRC with care. So that's all from me. Thank you.
All right, thank you, Krishna. And then right now, I would like to tell the audience how do we select our pump. So first and foremost, as I said just now, we have a composition of 0.987 acetic acid and 0.013 water. And then based on this volume, and our flow rate is 137.895 gallon per minute at 95 degrees Celsius. So based on this data, we can after a series of calculation done in Excel, which we're going to submit in the Putra Plus later, we got the total head loss is equivalent to 180 feet, and since our volumetric flow rate is equivalent to 137.895 gallon per minute, the matching pump curve is 3x4-13 centrifugal pump operating at 1,780 round per minute. So based on the pump curve that we selected, and then we overlap the pump curve with the SRC that we had developed, we can get the operating point and desired operating point by overlapping the two figures. And then now look at the figure at the bottom. There's two lines, which is green line and blue line. The blue line is our desired operating point, whereby the green line is our operating point. And from our operating and by intersection of the pump curve and with our system resistance curve, we get the suitable pump. The suitable pump characteristics is with a centrifugal pump with a impeller diameter of 12-inch with efficiency of 56%, power input 13 horsepower, and its MPHHR is equivalent to 1.1 feet. So and then like what my teammate Krishna has said, we need to design a safety margin in order for us to select appropriate pump. And a 1.1 margin is used, whereby our MPHHR will be equivalent to 1.21 feet. And then after a series calculation done, we get our MPHHA is equivalent to 55.7. This MPHHR is get after we subtracted the vapor pressure and all the minor losses in our suction line. So finally, we get our MPHHA is equivalent to 55.7 feet, which is greatly higher than 1.21 feet. Since our MPHHA is greater than 1.1 MPHHR, therefore, the 3x4-13 centrifugal pump operating at 1,780 RPM is suitable for our systems. All right, now I would like to invite my last teammate, Alif, to tell us about the advantages and disadvantages of using a centrifugal pump.
Okay, thank you, Lee, for inviting me. Okay, the advantage and disadvantage of the centrifugal pump. Firstly, we can see the centrifugal pump is a very simple pump because they do not require any valve or many moving parts. It means that the device or the pump, it is very easy to the handles. But in terms of the costing, we can see it is very helpful to the workers who want to repair the pump, because it doesn't require a lot of the what we can see as the valves, T-valves, or any minor or any valves or valves T any valves, T or other substance that contribute to the minor losses. Next, we can see that most of all, they are very small compared to other types of the pump that create the same outputs. It means that it is a very compact, and it will help to save more space other than using the other pumps. Next, we can see that why we choose the centrifugal pump is it has perfect for transporting hazardous materials. So due to its characteristic, which is help to protect the other the peoples who use it. So it is very helpful to prevent the workers who use the pump from from exposing themselves from the toxic like what we can say kerosene, gasolines, and other chemical substance which is will harmful to the human. Next, we can see that science there are no drive seals, so there is no risk of the leak. Drive seal is a device that we use in connecting or we want to join the system in order to transport in tube size. So basically, in other pump or in many pump, it will in many pumps. So when involved with the tube, so the risk to what we can say the risk to develop leak is very high. So in this centrifugal pump, we can see that there are no drive seals. It means that there is no risk of the leak. So it will help. It will help in costing of the pump. Next, we can say it is less frictional losses because it doesn't require a lot of the valves or other device that contribute to the minor losses. So disadvantage, we can see that centrifugal pump use rotation instead of the suction to the move of water. So when the water flow into the centrifugal pump, we cannot control the flow rate of our desired. So it is very difficult to determine our flow rate of the water if we use centrifugal pump. So next is cavitation, when the speed of the water causes it to vaporize, which cause bubbles in the liquid. A combination of the speed of the vapor bubbles and the implosion of vapor bubbles can be corrosive to the impeller surface and pump casting. So we can see that this advantage is related to the first advantage, which is we cannot control the speed of the water, the flow rate of the water. So we can see that it will damage the device inside the centrifugal pump, like the impeller. So it will cost a lot of money to replace and repair the device. That's all from me.
All right, thank you, Alif. Now I would like to add on some information about on Alif's point. Just now, my group mate Alif, he's mentioned about cavitation. Actually, cavitation is a very normal phenomenon occurs when choosing a pump. Therefore, we have to calculate the MPHH value of the pump appropriately in order to prevent such accident. Actually, MPHH, it means net positive suction head. Therefore, and then, as I said just now, our MPHH air value is greatly greater than the MPHSR value. Therefore, the pump that we selected is absolutely suitable for our system. And however, there's this disadvantage on the centrifugal pump. However, its disadvantage can be overcome by appropriate design of the system. Overall, I would like to say that centrifugal pump is definitely a very simple yet most general pump to use. This ends our presentation for our fluid mechanic project today. And before I end our presentation, I would like to thanks to my teammates for finishing the project together, and for Dr. Nordin, thank you for lecturing us, and all the detailed calculations and report has been submitted in the Putrablatt. That's all for our presentation today. And now I would like to say thank you, Doctor, and that's all. Thank you. Goodbye.
Thank you.
Thank you.